Hey everyone, and welcome to this explainer. Today we're putting the spotlight on some absolutely phenomenal breakthroughs coming out of India right now. We're talking about updates that are literally shaping the future of science, technology, and national defense. From mapping out uncharted ocean depths to harnessing the power of generative AI in the fight against cancer, the sheer scale of innovation we're looking at is just staggering. So let's jump right in. Okay, let's dive into this. Here's our roadmap for today. First up, marine and ocean discoveries. Then AI and cancer research, and finally, national development and defense. So, Part 1, Marine and Ocean Discoveries, Exploring the Deep. 2.37 million square kilometers. That is the massive, almost unimaginable scale of India's Exclusive Economic Zone, or EEZ. The Center for Marine Living Resources and Ecology just released an unprecedented document called the National Report on Deep Sea and Distant Water Fishery Resources of the Indian EEZ. Just trying to wrap your head around charting an area this enormous is completely mind-bending, right? But honestly, the sheer dedication it took to compile this report is even more impressive. Because the immense effort behind mapping the zone wasn't just a quick survey. Not even close. The center, operating under the Ministry of Earth Sciences, compiled nearly 4 decades of rigorous oceanographic research, plus 3 decades of systematic surveys. We're talking about data gathered from more than 400 separate oceanographic cruises, including specialized expeditions aboard the research vessel FORV Sagar Sampada. It is literally decades of hard science, sweat, and sea salt, all distilled into one comprehensive report. And here's what they were actually out there looking for. The report assesses a huge variety of marine life across different ocean layers. They mapped out mesopelagic resources, which, by the way, are found between 200 and 1,000 meters deep, alongside demersal or seabed resources. They also tracked distant water species like tunas, sharks, billfishes, and even Antarctic krill. Now, the so what here is absolutely massive. Mapping these specific resources across varying depths is crucial for understanding India's marine ecology, and it ensures that these underwater ecosystems can be managed sustainably for generations to come. Now, let's pivot from the macro scale of millions of square kilometers down to the absolute micro scale. Scientists have just discovered 2 entirely new species of microscopic marine organisms. They're called Samophaga holtzmanni and Samophaga sinhai. They belong to a group of single-celled organisms known as foraminifera. But the name Samophaga is what I really want you to remember here, because it literally translates to sand eater. It's a highly memorable name for a tiny creature with a very peculiar appetite. Now, what's really interesting about this is exactly what these tiny sand eaters are choosing to dine on. They selectively consume heavy minerals. We're talking about titanium and iron, particularly minerals like ilmenite and magnetite. And what makes this behavior so fascinating to scientists is that these heavy minerals are only present in absolute trace amounts in the surrounding seabed sediments. There's barely any of it down there, yet these microscopic organisms actively hunt them out and consume them. This remarkable discovery was made by scientists from the Agarkar Research Institute in Pune. They found these creatures at Rajapuri Creek in the Raigad district of Maharashtra, right along the Konkan coast. This discovery is a brilliant reminder of India's largely unexplored marine biodiversity. Understanding how these microorganisms interact with seafloor minerals could seriously unlock new secrets about marine ecology and the biological processes happening deep in ocean sediments. Moving on to Part 2, AI in Cancer Research, featuring the MuteAIverse platform. I really want to introduce you to a powerful new tool called MuteAIverse. This is a generative artificial intelligence platform developed collaboratively by researchers from IIT Delhi, the National Institute of Pharmaceutical Education and Research in Guwahati, and the CSIR Institute of Genomics and Integrative Biology. The primary mission of MuteAIverse is absolutely critical: to investigate and identify possible environmental exposures that are directly linked to causing cancer. And this brilliantly illustrates exactly why MuteAIverse is a total game changer. Previously, researchers relying on the old DNA adduct reference library had fewer than 400 entries to work with when they were trying to match DNA damage to a root cause. But by applying generative AI, the MuteAIverse platform expands that library to over 300,000 potential entries. I mean, that is a staggering technological leap. It gives scientists a vastly expanded dictionary to help translate exactly how environmental chemicals are damaging human DNA. So, how does this all actually work in practice? The process is quite elegant, really. First, they take mass spectroscopy data from actual tumor biopsies. Second, they run this data through a specialized machine learning tool called a duct linker. And finally, this AI analysis works backward to trace the specific DNA damage, the DNA adducts, to possible genotoxins or carcinogens out in the environment. It essentially acts as a highly advanced molecular detective, linking the biological damage inside a patient directly to the chemical exposure they experienced on the outside. All right, part 3, National Development and Defense, focusing on skills and security. Starting on the ground, West Bengal just hosted its inaugural Kausal Mahotsav mega recruitment drive in Balurghat. Spearheaded by National Skill Development Ministries, this acts as a vital bridge. It directly connects newly certified, skilled local youth with major corporate employers who desperately need their talents. It's a huge step for regional workforce development, bringing real, tangible opportunities directly to the communities that need them the most. Now, shifting gears from jobs to national security, I have a question for you to consider. How exactly do you safely test highly critical, incredibly complex submarine rescue technology without going through the immense risk and expense of actively deploying it out to sea every single time? Well, the answer to that engineering puzzle is the Indian Navy's brand new shore-based launch and recovery system, or LARS, test plinth. This is a state-of-the-art onshore facility designed specifically to solve that exact logistical and safety problem. So the crucial point here is how this facility actually operates. Located at the Submarine Rescue Unit in Visakhapatnam, which also happens to be the headquarters of the Eastern Naval Command, this test plinth is designed to test, validate, and maintain critical rescue equipment. Most notably, it handles the Deep Submergence Rescue Vehicles, or DSRVs. By having this shore-based facility, the Navy can ensure these life-saving vehicles are perfectly maintained and validated, completely eliminating the need for complex and costly active sea deployments just to run a diagnostic test. It basically guarantees maximum readiness with maximum safety. Wow, we have covered an incredible amount of ground today, from millions of square kilometers of ocean mapping down to microscopic sand-eating foraminifera, from an AI that tracks cancer-causing chemicals all the way to a shore-based testing facility for submarine rescues. It really highlights the incredibly diverse fronts on which innovation is happening right now. So I want to leave you with this final thought. Of all these milestones, which one do you believe will shape our future the most? Thank you so much for joining me to explore these fascinating topics today. Keep learning, and I'll catch you in the next explainer.